Webinar today with the topic Deep Learning on AWS. A warm welcome to our great set of speakers who will take us through this session, giving us great insights on deep learning on AWS. It's a pleasure to have you in this webinar. This event is hosted by deeplearning.ai and AWS Cloud Educate student ambassadors who've done a great job in organizing. From this session, we expect to garner knowledge on how to get started with AWS on starting our journey on AWS Cloud Services. We also expect to learn best practices of developing and deploying deep learning models on the AWS cloud. We'll also get to discover how companies are disrupting and transforming various industries by building fast, scalable, and flexible machine learning models on the cloud. Couple of things to remember during the webinar. Our speakers will answer your questions at the end of the webinar. Please feel free to post them on our Slido platform using the link provided. Also, keep posting the proceedings of the events on Twitter, LinkedIn, and all other social media platforms that you wish to. Use the hashtags, hashtag AWS Educate and hashtag deeplearning.ai. I repeat, hashtag AWS Educate and hashtag deeplearning.ai. Before we start, let's have a greetings video from Dr. Andrew Nju, the founder of deeplearning.ai.
Hello, deep learners. I'm Andrew Ng, founder of deeplearning.ai, and I'm excited to welcome you to our global deep learning community. I know that many of you are here today because you want to break into AI and build your career. I hope that being part of this community will help you to do so. To give you a proper welcome, I'd like to show you around the deeplearning.ai offices and meet some of the teams so that you can see where it all happens.
Oh, hi, Andrew.
Do you want to tell our friends at Pine AI what you do at deeplearning.ai?
Sure. Hi, everyone. I make articles and other media that help people learn about AI and help them understand the huge impact that AI is having in the world. Today, I'm putting together the next issue of The Batch, our weekly newsletter, and I'm looking for the biggest stories of the week to keep our readers informed.
What's been the most surprising thing you've run into working on The Batch?
How much is going on in this field? There's never a dull moment. You might think from the outside that machine learning engineers really understand everything about AI, but nobody understands everything about AI because this field is just coming to life right before my eyes as I put this thing together every week.
All right, I know you're really busy, so I'll let you get back to it.
Thanks. See you later.
Let's go meet Kian, who helped me create the deep learning specialization. He's working on an exciting new project. Hey Kian, so do you want to tell the people at Pine AI what you're working on?
Yes, sure. I'm leading a project called Workera, focusing on helping people get offers in AI and navigating their career by testing their skills, preparing for interviews and certifying them, as well as matching and referring them to good jobs in AI.
That's really cool. And what's the most exciting part of your day?
You know, the AI field is new. Organizations and jobs are still misunderstood. So I'm excited to help people understand what different types of jobs exist in the field, what tasks they will work on, and what skills are needed to achieve those tasks.
That's really important work. Well, it's nice chatting. And now let's go chat to Hotel, who is on their product team. Do you want to say hi to our friends at Pine AI and let them know what you're working on?
I would love to. Hi, everyone. I lead the product team in deeplearning.ai, where we create AI education content accessible to people all around the world. People like you.
And what are you most excited about right now?
I am so excited to see our community grow and to see how eager people are to learn more about AI.
Thanks, Osel.
Thanks, Andrew.
So, as you can see, our team is working hard to support you and help you learn. It's never been easier than before to break into AI. So if you want to build a career, you can leverage online resources available, including open source code, datasets, papers, and online courses like a deep learning specialization on Coursera. As part of this journey, I hope you get your hands dirty too. Don't be afraid of diving in to build your own project, or go ahead and try to replicate a research paper that you're excited about. One thing that I've seen help a lot of people succeed is if you can build a community or find a community of fellow deep learners you can meet with and study with on a regular basis. In fact, I hope that this Pine AI meetup that you're at right now will be a good place for you to meet these people. I hope you enjoyed the event today and that you learn a lot, both from the talks and from each other. And once again, welcome to the deeplearning.ai community.
Great. Now we are ready to get on with the session. We'll begin with our first speaker, Mr. Jianjun Zhu, who will take us through the first session, getting started with AWS Cloud Services. Therefore, without further ado, welcome, Mr. Jianjun.
Sorry about that. Do you hear me now?
Yes.
Oh, great. Can you see my screen? Okay.
It's visible.
Excellent. Hi, my name is Jianjun Xu. I'm a senior solutions architect with AWS Education. So AWS Education is a little different from the program you guys are working with. That's AWS Educate. That's focused on working with students. AWS Education, we work with researchers and institutions, universities and institutions, helping them doing their research. So I started my career as an astrophysicist, did numerical simulations. Then I went into building softwares for NASA to process satellite images. I joined AWS about a year and a half ago. So far, this is the best company I ever worked for. I hope some of you guys, after you finish your study, consider joining this our AWS team. AWS is not only, for me, in my opinion, is not only the best place to work, it's also the best place to run your machine learning. So let me just get started with the service because I only have 30 minutes. There are over 300 services and thousands of features in AWS. I won't be able to go through all of those. I'll be focusing today on the data analytics and machine learning services we provide to you. Hopefully you will have a little bit idea, at least at the highest level, where to look for more information when you are considering doing machine learning. So I will start with an introduction to some of the basic services, including compute, storage, network, and security. Those are the foundations of anything you do in the cloud. And then I'll focus a little bit on, I'll put all the pieces together and give you some higher level pictures of how you do data analytics on AWS and how you do machine learning on AWS. I know there are lots of experts today is going to walk you through some of the details, how to do machine learning and deep learning. So I won't go really deep in that, but I will give you a higher level, bigger picture of how to do those things on AWS using our services. So let me first just introduce, give you some, for people who are not really familiar with cloud computing or AWS, a brief, give you a good basic idea what cloud computing is and what kind of services we're talking about here. So cloud computing is, it's considered cloud computing very similar to the way you use electricity. You go into a room, you turn on the light, and then you start using the electricity. When you leave the room, you turn it off. So it's on demand delivery of, instead of power, it's actually on demand delivery of IT resources via the internet. and you pay as you go. That will help you to reduce your cost of instead of running a large data center and then not 100% utilized. You still have to keep it on when you're not using it. Cloud computing is when you're using it, you pay for it. When you're not using it, you don't pay for it. And instant scalability is a really important piece, especially for people are doing a very large amount of computing, high performance computing, parallel computing, or machine learning. Sometimes when you're doing image processing, you will need multiple GPUs and very large machines for a very short period of time. In order to do that, normally you will be getting budget in place and get financial approval and buying those machines. But now with the cloud computing and AWS, you don't have to do that. You just go provision an instance. For example, our P3 16 extra large. It's multiple GPUs, very large machines, hundreds of the virtual cores, and you can use. You can run your image processing for an hour or a day, and then you can shut it down. And you don't have to worry about the cost of those large machines. Instant scalability is really important in research, especially. So what's the benefit of using a cloud service like AWS? Agility, cost saving, elasticity, and with all those benefits, let's say if you're a researcher, you're doing large-scale genomics research, right? So instead of provisioning those large arrays of computers to do data analytics or build your model, you instantly get access to large amount of compute. That's the agility we're talking about. And then the amount of money you pay is a fraction of what you have to spend on your data center. With all this benefits, you can start innovate really fast. If you have a model, which is really important in higher education or research, not all the ideas you come up with are good ideas, right? But you want to try out. You want to try those ideas to see if it works. With those agility and elasticity, and you can experiment with your idea really fast. That's what we mean by innovate faster, right? And also, if you need to touch an audience around the globe, then you can go global in minutes. I'll show you a little later how you can do that with our global network. So those are the core services are the storage, compute, network, security. Those are the foundations. And then on top of that, we build special purpose-built databases, and then the frameworks we put in place so you can do AI, ML. So before I introduce individual services, let me just touch a little bit on the global network we're talking about. So AWS has 24 regions. Those are basically geographic locations around the world. A region is consists of multiple availability zones. You can think about availability zone as clusters of data centers, not just one data center. We have more than, I usually have 2, 3, more than that in some regions or AZs. Those are the cluster of data centers that are connected with very high speed network cables. So they are also designed for disaster recovery. So, and for example, a local event, a flood event, for example, won't affect more than one data center. So we have 76 availability zones that help you to deploy your workloads or servers or services highly available. And then we have one local zones in Los Angeles that is really close to large institutions or enterprise that they can run their workloads really, really fast to the cloud. We also have over 200 points of presence. Those are the caching areas. Kennedy, is there anything you can do with the so people won't be able to write on the screen?
Live down, live somewhere else. 6,000 got eyes. This is me, nó sai biết cái
đi魔风你要风马快乐，东风天天到处冲，人也落。
Sorry for that. You can go ahead. Sorry for that technical hitch.
That's okay. Yeah, let me start the sharing again. All right, so let's talk about compute a little bit. So there are three different types of compute you can use in AWS. The EC2s are the traditional virtual machines that you can provision. We have over around 200 different sizes and types of machine that you can use. The middle part is the container. So it's really useful for people who are actually doing machine learning nowadays in the cloud to get familiar with the containers. So we offer different services to run containers. Later on, if I have time, I'll show you how our machine learning services are being containerized and deployed in the cloud through things like ECS and EKS, the Fargate, and also Kubernetes. And then the service on the right-hand side is called AWS Lambda. This is the serverless option. If you want to run certain workload, but you don't want to provision hardwares or worry about the servers, then you can use our AWS Lambda function. Those are serverless functions that you can do your compute in the cloud. Really quickly. So we support pretty much all the platforms and OSs that here. This is the basic workflow. You deploy. You started with the AMI. A lot of our we provide a lot of deep learning AMI. So those are machine images that you can use to spin up EC2 instances. And then you can deploy your instances in an availability zone inside a virtual private cloud. That to make sure that you have all the securities in place and prevent unauthorized accesses. So when you spin up a virtual machine, you select a processor type, and then you get access to things like NVIDIA graphic cards, AMD chips, and ARMS is Amazon purpose-built chip to provide you with different types of compute at a very much lower price. This is a special of all the instances. We range from just based on your workload, you choose different types of compute. For machine learning, for example, our largest instance, 16 extra large, that has 64 virtual CPUs, 128 gigabytes of memory, with total eight of V100 Tesla GPUs, and the total video memory is about 500 gigabytes. So you can run really large, build really large models on those machines. And then you can put all those machines together, create a cluster, and then run them in parallel. The way you pay for those services, you can either use on demand, or if you know that your workloads, how many virtual machines you're going to use, what type of compute you're going to need, you can actually buy those things in advance at a much lower price. Or if your workload so have I been sharing the wrong screen the whole time? This is getting
Shut up, you nigger. Those middle fingers are for you.
So we also built our own system called Nitro system. Those are the chips that with specific cards on our hardware to improve the performance of the network and storage. And then let's talk about storage a little bit. So there are 3 different kinds of storage: block storage and file storage and object storage. So object storage is probably something that you guys are going to use a lot when you're doing machine learning. It's called S3. It's different from the regular file system or the block storage you're talking about, you're familiar with. So let's just leave it at that level. And once you put something in AWS in an object storage, it will become really highly available. So if you look at those numbers here, once you put a file in AWS S3, the object storage, we actually make more than 3 copies in different data centers. So you will never lose that data. Those are the different types of storage. We also have different ways for you to move your data to a cheaper location. Let's say if you have a large amount of data, you want to do some data processing, you can put it in S3. Once you move it over, once you finish processing those data, we'll have services to move them automatically to a different class of storage. So you don't have to pay too much for that. And then if you have a large amount of data you want to move to the cloud, we actually have those devices. You can put terabytes and terabytes of data. If you have petabytes of data, you can actually use something called a snowmobile that can move 100 petabytes at a time into the cloud. Networking, so I'm not going to dive really deep into that, but anything that you can do in your local data center in terms of the networking, creating subnets, create different virtual private cloud VPCs and routing, and also you can use direct connect and all this to connect to your on-prem database data centers. Those are the typical things every data center needs to be done, can be done in the cloud. And also the one very good big benefit of doing that in the cloud is you can write code to do those. Infrastructure as code. You can spin up a data center in the cloud really quickly with code. Security, of course, is really important. Anything before you do any work in the cloud, you need to think about security. So we have a shared security model. All the services we provide, I mentioned compute, storage, and database and networking. Those are our AWS responsibility. We take care of the security of those. But when you are putting your workloads or building a model or putting data in the cloud, and you need to worry about the things on the top. How do you configure your network, firewalls, how to protect your data, how to encrypt your data. Things like those are your responsibility, but we provide a lot of security features for you to build those features, security really, really easily. So those are just a list of the services that you can use to secure your data and network. So we provide native encryptions to help you to encrypt your data when your data is at rest or when it's in transit. You can protect those with those services we provide. So those are really, I know it's really fast, and those are the basic services we provide. And then on top of that, so let me, the data analytics, I can talk about that for days, but because we have a very short time, I'm going to just start with this picture here, and touch on some of the services we provide. So you can do the entire data analytics pipeline in the cloud. So on the left-hand side, this is where your data source is. Normally, you have a ERP or a learning management system, student information system, those things, or you can have individual users, their mobile phones, their IoT devices. Those are all your data sources. In AWS, we provide a large array of those services for you to host your service. For example, we have streaming platforms, so you can produce videos and images. And then we have IoT devices, like you can connect to the data stream to send data in real time. And then we have our purpose-built databases that you can build your application on top. All those data sources will send data into the cloud. So then you can build your pipeline. Glue is an ETL service. We use to ingest data, and then once the data is in the cloud, sorry about that. Once the data is in the cloud, you can use something like AWS Batch to process those. And then if you have real-time data, you can use Kinesis Stream and to process Lambda, use Lambda function to process those data to put in a data lake. A data lake is a new concept. It's compared with the data warehouse, it's a lot more flexible, and you can put a lot, and it can process a large amount of data. It's perfect for big data and also for real-time streaming data. Once you put it in there, you can build a data catalog on top, and those are the services that you can use to deal with those data. And then once the data is ready, then that's usually, it will take, this part of the process will probably take you 70% of your time to get your data in a good shape. Once you do that, you can feed it into your machine learning or perform data analytics. Now, all those components of the data pipeline can be built with or without server in the cloud. So I'll talk about the really high level, what AI ML look like, how to do AI ML on AWS. I know there are more experts talking about the deep learning later on. So for machine learning, you can pretty much do machine learning in all different industries and different areas, right? So we talk about natural language processing, image or video and analytics, to forecasting with financial data. And then for healthcare and life science, we do a lot of genomics research, performing building models and to predict, for example, from X-rays or chest X-rays or MRI images to perform diagnostics of diseases. In manufacturing, smart manufacturers, smart floors are all hooked up with IoT devices. Those are the ones that sending a large amount of data. That with the data, we can do real-time analytics, build use RNN to build real-time analytics, and reinforcement learning can be used in building autonomous vehicles, driving vehicles. Things like those are all, we have examples in our SageMaker environment. I can show you a little bit later that how you can actually start really, really quickly just by start from a sample example Jupyter Notebook. So this is a limited, this is just a collection of our customers. They are currently doing machine learning on AWS. To support our machine learning services on AWS, we built a lot of different services and instances, large machines for you to do training and also for you to do inferencing. So those are the instance types. But one thing I want to mention is this new inferential chip. This is the chip we built just for you to perform inference at a much lower price. So the stages of machine learning is like you start with data, you build a model, right? And then you feed your training data into that model, and then you tune the parameters and you build the model itself. Once you build the model, you have to make your model available for other people to send their data and just get the predictions. Those are the inference we're talking about. Normally, you use a large machine to do the machine learning training. You spend a lot of time doing the training, but once you are done with the model, the inference doesn't take a lot of compute, but they sometimes require a large array of capabilities to process large metrics, right? So to use a large machine with a lot of GPUs to do that inferencing is a waste. So we built this inferential chips just to solve that problem. It performs certain tasks, the inferencing tasks, really, really fast, and it's much cheaper than having a GPU machine up in there running all the time. So that's something that keep in mind when you're building your models. This is the machine learning stack. So there's a lot in this, but in general, there are 3 layers. So if you are, for you guys, you're thinking about becoming a machine learning practitioner, so you'll probably need to build your own models. So this is what you use. The lower layer is called the frameworks and the infrastructures. We support TensorFlow, MXNet, and PyTorch. We invested a lot in MXNet recently. We built a lot of models. A lot of the SageMaker algorithms are built on this with this framework. And then there are higher level frameworks and the Keras and the gluons. And also once you build the model, you need to run on certain machine. You used to have to provision the machine, install all the Python packages or the libraries you need. And then you need to choose how many GPUs, or you can only work with what you have, right? But for us, we build all those on the right-hand side, the lower level, that are AMIs, and we containerize those AMIs. And then that's why I mentioned a little earlier that for getting familiar with container is really helpful, is that whatever you want to do, and I want to run MXNet model on a machine with 6 GPUs or 8 GPUs. You can just call up one line of code in SageMaker, says, I need this. And then we all spin up those containers and put your code in this container and connect with your data and run it in that container. So you don't have to provision a machine. So make it really, really, really powerful. So for the SageMaker Studio, this is the Jupyter Notebook environment that you will be building all your algorithms. So let me check the time. And then on top of that, we actually build really a higher level AI services. So you can do vision, speech, text, chatbots, all without writing code. So those are the high level AI services. If you go to AWS, I believe you all have AWS Educate account now. Then you can go play with those services, upload the image and see what information you can extract from that image, or build your own chatbot. Use Lex. Lex is the chatbot behind Alexa. All those services put together, and then you'll be able to do your machine learning a lot easier. Yeah, here are the service names. Those are the components of the service. I'm just run through really quickly the building models in SageMaker. SageMaker is our machine learning, the go-to solution. The first thing you want to try after you log into AWS, I would just strongly suggest that you look up SageMaker and SageMaker Studio. So for supervised learning, we have all those. These on the right-hand side are deep learning. You can use a couple line of code to start your object detection. I might have time to show you a screen of SageMaker with the object detection and the image classification. And those are the unsupervised learning. You can use PCA to do dimensionality reduction. And then once you have your data in a better shape, you can use k-means, for example, to do the clustering. Those are the existing services. Then you can just use APIs to call and in your Jupyter Notebook to run. You don't even have to build a model. We already built the model for you. You just need to provide your data. So SageMaker Studio is a new service we released recently. It's built on top of the SageMaker, the Jupyter Notebook. It provides an environment for you to be able to track your experiment and also provide debugging. to go through your in the process of building your model, you will be able to do that. So I am gonna end here and also spend a couple of minutes to show you what the SageMaker environment look like. So here's my email. If you have any questions, you can send me emails. And I strongly suggest you, if you want to do a deep dive into the deep learning, the D2L.ai is a very, very good free resource for you. They got a lot of sample code you can just run directly in SageMaker. So let me just take a couple minutes. I know our time is up, and I'll show you really quickly the SageMaker environment. So once you log into the console, and then you start up your Jupyter Notebook, this is the button I want you to click first. The SageMaker examples, all those a list of examples that you can use. And one more example. So this object detection, you use the P3 instance. You start your SageMaker session, and then you show us where your data is. In this case, it's in the S3 bucket. And then this is the part that really is the key of this model, right? You're basically telling me that you need to run, you need to build an object detection model in SageMaker, and then we'll get you this container image. Once you have that image, this part is just looking at the data, processes the data. This is all you need to do to build your model. Your object detection model is that I'm going to use this container I specified. It's called object detection. And then I'm going to run this in this P3 instance that has 1 GPUs. And then these are the hyperparameters, or some of the parameters I'm going to pass you. And then once you get that, and then you feed the data, you set the hyperparameters here. And then you call this OD model.fit. And then this is going to train that model. This is all the training that you have been doing. And then you put that model as an inference, as an endpoint. This is all you need to do. And then here we go. So we pass the images to the model, to the inference point. The inference will come back with the name of the object and also boundary boxes of those object models. This is the really easy way to start your deep learning. And then those are just different examples of those. So yeah, with that, I think I don't want to run over time. So thank you so much for having me here today, and let me know if you need any other follow-up, Kennedy.
Thank you so much, Mr. Jianjun Su, for that enlightening session that you've taken us through. It was a comprehensive introduction to AWS for data analytics and machine learning. We thank you so much for your time and for sharing your experience and your knowledge with us today. Just a few announcements. A reminder that all questions will be answered at the end of the session by our speakers, and also continue posting your questions on the Slido platform provided on the link, and also keep posting on social media platforms using the handles and the hashtag mentioned. I will take this moment to welcome our second speaker, Mr. Ewere Diaboya. Mr. Ewere will be taking us through building fast, scalable, and flexible machine learning models on AWS Cloud. Thank you, Mr. Ewere, for taking time to join us today. Welcome.
Hello, thank you very much. It's a pleasure to meet everyone here. So today I will be talking about something a little bit different from what was mentioned, but I'm going to also delve into it. So most of the part of my talk will focus more on something not so different, but something that is more like what you need to do first of all before you start talking about building of machine learning models. So first of all, I'm going to introduce myself. My name is Ere. I'm the first AWS community hero in Africa. I've been a software engineer since 2003. Used to write Visual Basic code then. And then I'm the co-founder of DevOps Nigeria, where we have over 2,000 members currently as we speak. I was also the first speaker at the first AWS community meetup in Nigeria. I was the only speaker representing Nigeria at AWS Loft at Joburg. I'm a blogger on YouTube. I also blog on my own Medium account. I'm also a speaker too, and I'm a cloud and DevOps engineer, and I am a father. So without further ado, let's go straight into data engineering and talk about how AWS helps us with end-to-end data engineering and making data available and preparing data for machine learning, building, and deployment. So first of all, we'll focus on what is data engineering. So data engineering is an aspect of data science that focuses on practical application of data collection and analysis. For all the work that data scientists do to answer questions using large data sets of information, there have to be mechanisms for collecting and validating that information. In order for that to work ultimately have any value, there also have to be mechanisms for applying it to real-world operations in some way. So the major tasks involved in data engineering include collection of data, cleaning up of the data, and then loading that data into a particular environment or location for analytics or performing analytics on that particular data. It involves various simple and complex data pipelines that perform what we call an ETL continually. So ETL means extraction, transformation, and loading. So basically, data engineering focuses more on extraction of data, transforming of the data, what we call cleaning of the data. Basically means we're trying to prepare the data for training on the machine learning models or for AI activities and for training of models, both for machine learning and for deep learning. So there are certain things we need to know and understand before we go a little bit deeper into this session. So I'm trying to highlight them one after the other. The first term we have here is called extraction. So this means collection of data from different sources. So different sources could mean an application in a server, could mean from a mobile device, could mean from a website, could mean from any other kind of wearable device. So it means collecting that data from that particular form and from that particular device. The next is about transformation. So what does transformation mean? Transformation talks about cleaning of data, which means preparing that data for the next stage and ensuring that that data, it meets certain standards and conforms to certain principles that you need that data for. Loading means writing that data to the location to be used for further analysis. So when you extract the data, you clean up the data, you make it in a particular form that is more usable, and you load it. So that process is what we call an ETL process, extract, transformation, and loading. The other term that are so important is what we call a data swarm. So before you perform your ETL process on your data, you might want to dump your data into a particular location. And within that location, you don't intend to do anything. You just dump the data for the purpose of trying to scan through and understand what is actually in that data at that point in time. So what you do is you dump all the data from the different sources and the different locations where you have data stored. So it could actually be streaming data, which is data that comes in real time, or it could be data that is actually dumped already there that you have to extract. The next we have here is what we call a data lake. So a data lake is a location for storing raw or semi-clean data. So you can actually call data that you have, say, partially transformed, that is in a location, a data lake, because the importance of a data lake is where you start fine-tuning concepts of what you intend to use that data for. Data lake is where you go to actually see what has been done so far in terms of cleaning up that data. So data could be in form of images, where you collect a lot of images, but you want to train a particular deep learning model to understand certain kind of faces. Now, some images might not meet up to your requirements. So you might need to be able to clean up a lot of the images you get and extract and filter out the particular images that you are going to use to train your model, because good data means good model, means good prediction, and means intelligent and more powerful artificial intelligence. The next we have here is data mart. So data mart is a business layer structured to give different business functions insights. So basically, data mart is more of a subsection of a data warehouse, which is the next term. So some business functions will want to get some kind of 180-degree statistics of, say, a staff of a company. So from, say, all the salaries the person have been paid, all the promotions the persons have gotten, all the taxes the person have paid. You just want to get a 360 degrees of that particular individual. So that could mean getting data from HR, getting data from accounts, getting data from different departments, and sectioning it to just what account needs to see and understand about that person. It could also be customer data. You just want to understand the spend of a particular customer at a particular point in time, and you tailor in that mart into a specific part of the person's life, which could be maybe spend on data in a particular month. So that's what we call a data mart. So it gives a business layer, a specific business layer. It could be account, it could be human resource, it could be operations, details of a particular insight or data. The data warehouse is a combination of all data sources to form a summarized 360-degree view of all company and business data. So basically, I mean, the warehouse is where the C-level executives make their decisions and their final says. It is where we combine all the data of the business, all the data from different departments to form a holistic 360-degree view of what is going on in the business in terms of accounts, human resource, operations. And also for the part of applications, when you have a data warehouse, it serves as your source of truth for anything that has to do with your applications and your services and what is going on at any particular point in time. So it's the most powerful and it's the heart of your system and where everything happens. And then the last is more of a concept which we call data archiving and cold storage. So it's storage of data that is not accessed regularly but can be referenced on a later date. So data archiving is very important because you have organizations who have loads and loads of data. You might not necessarily need to keep that data in your data lake on your data mart so that you don't clump it up with data that you don't necessarily need. So you can actually section that data and move it over into an archiving or a cold storage that you don't often go to, but you go there once in a while to just pick out some data to use for analysis. So within AWS, most of those terms I just explained about data engineering actually have specific services that do them, and these are the services in AWS that are tailored towards each of those concepts and those terms in data engineering. So you have AWS Glue. AWS Glue is more of an ETL service for ETL operation. So AWS Glue is so powerful that it comes in with Spark, it comes in with Python, it comes in with a powerful ETL process that is fully serverless. So you write your jobs and give it to Glue. What Glue does is it takes the jobs, cleans up the data, and it also comes with Spark SQL. So you can actually pick data from your location or from your storage and clean up that data and rewrite it to where you want it to be. So AWS Glue is very powerful and does that very fast and quite efficient in doing that. The next we have is Amazon EMR. So Amazon EMR is more or less, I'll call it the more open source version of AWS Glue. So what EMR does is gives you the full access to the full blown Hadoop set of tools. So from Spark to every single service actually that the Hadoop stack has to offer, you have access to that. So when you set up an EMR cluster, you are able to set up many of those services like Scoop, okay, for extraction of data that comes with Hadoop. So those people who are Hadoop experts, they usually enjoy using EMR because it gives them that flexibility and that opportunity to explore and work with data extensively. Amazon S3 is a simple storage service which has already been talked about, and it's simply for storage of objects. So in some cases, I used to use S3 as a data lake because it can store almost infinite data. You can store as much as terabytes to petabytes of data in S3, and you can never exhaust the limit. So You can build strategies around making S3 a data lake for storing your data and partitioning the data accordingly. The next we have is the Amazon Data Pipeline. So Amazon Data Pipeline is an end-to-end ETL application. So Amazon Data Pipeline more or less replicates Amazon AWS Glue, but the difference is before Glue came up with the DAG flows, Amazon Data Pipeline had what we call a DAG flow. So a DAG flow is a sequential process that helps you to plan the extraction, transformation, and the loading of data, or it could be an extraction, a transformation, and transformation before the load of data. But what sticks data pipeline out is that it gives you a more visual form of the full ETL end-to-end process. It gives you a more sequential process. Just wasted functions are used for sequential processes. So Amazon Data Pipeline gives you a step-to-step sequential process for where you're extracting data from and where you are writing the data into eventually and what you want to do with that data. The next we have is lake formation. So based on customer demand, Amazon released lake formation, and lake formation is the building block of your data lake. So it has the features that come with data lake, features like proper data partitioning, security of your data, labeling of your data, and making it look more like a proper lake than improvising Amazon S3 as a data lake. The next we have here is Athena, which is another beautiful serverless service that is used for analyzing and for querying data. Basically, I call Amazon Athena the SQL for no SQL and for SQL. What that means is you can actually use Athena to query JSON, Parquet, ORC files, compressed data files. So it's always advisable to compress your data as part of your transformation process. What that does for you is that it saves you a lot of data transfer. It saves you time to query that data, and it also saves you time in terms of analyzing and getting a lot of insights from that data. So Amazon Athena is a beautiful UI that connects to S3 and queries your data in that form. So data Athena queries, like I said before, such as CSV, JSON, Parquet, and ORC. So Athena, you can practically run SQL statements, okay, and see SQL statements from Athena to query and read this data and get your output back in S3. The next here is Amazon Kinesis. So Kinesis is actually a family of services, okay? You have the Firehose, you have analytics, you have the video streams. So Kinesis is basically for streaming data. So when I talk about streaming data, I'm talking about, as we are on this video call, we are talking about streaming data, okay? As I'm talking, this data is being streamed to people all over the world watching on YouTube and also on this channel. So you can actually pick information from this from this stream and start analyzing it and getting insights into this. So Amazon Kinesis is very beautiful for that. It might not be video stream, it might be data streams, okay? When you're getting hundreds and thousands of users visiting your application, you're going to get a lot of traffic and a lot of data will be generated. You can pipe this data through Kinesis and perform a lot of analytics, analyzing and cleaning of data. We'll be looking at one of the case studies very soon on how we use Kinesis as a very beautiful tool for ETL and for data analytics process. The next we have here is Amazon Elasticsearch Service. So Amazon Elasticsearch Service is a service that helps you for analyzing data. So Elasticsearch is a unique service that is very good in terms of it's an out-of-the-box search engine, okay? When you write data to Elasticsearch, Elasticsearch has a beautiful algorithm written in Lucene that helps you to perform similarity search of data. So instead of the way you query for data in a normal database, Elasticsearch has a method of creating priority for your data and gives you results that are related to each other. Instead of giving you verbatim results or giving you results that are not related, Elasticsearch gives you related services, which is very, very good and important when you're trying to analyze data and you're trying to get things that are similar or things that are not similar. So Elasticsearch service is very beautiful and very good for that operation. The last we have here another list is what we call Amazon QuickSight. So Amazon QuickSight is the face of everything we are looking at. So when you've extracted your data, you've transformed your data, you need to bring out the insights that people can understand. When you are publishing reports, okay, for the C-level executives, for the accounting team, for every other part of the business, you need to put that data and represent it in a graphical form that they can look at, they can understand, and they can actually extract deep insights from. For example, you want to know, how many people globally are using a particular service in AWS, in what part of the world they are using that particular service, what is the frequency of females to males that use a particular service, what is the frequency of males to females that are in cloud computing field. These are the kind of insights that can be given by QuickSight based on the raw data that you have performed ETL process on during the whole process of all the services I've spoken about. So Amazon QuickSight, it's the face of your data. It's what gives you insights in a graphical form using things like pie charts, bar graph, histogram, and every other visualization tool you know about. So QuickSight is very, very good at that. So without further ado, let's be a little bit realistic with a practical case study. So let's not just talk about the services and talk about data engineering. Let's look at a real life scenario and how data engineering and machine learning was able to help. So the problem statement here is there's a marketing company that collects data of users from various channels, which mostly includes web campaigns and mobile ad bidding. This data includes cookie data, location data, user journey, and more. Due to the various databases used to build the campaign service, some data are actually structured as relational and some are unstructured, which could actually be data that could reside, say, in MongoDB, in Elasticsearch, or any other kind of NoSQL database. Now, the tech team have been tasked with creating a machine learning model based on this data that can help predict user journey based on historical data, which will help to improve the performance on future campaigns. So this is a very real life scenario of something I've worked on personally. So this was a real problem, and we needed to look at data engineering and look at the AWS tools that we could, fix together to actually solve this particular problem and, generate more value for our customers and then bring more to the business. So what we did was to think about how we could actually work it out. So we created a scheme of how this was going to be resolved, and this was the flow of the solution. So the first thing was to extract data from various databases, both those used by the applications and the databases that were output data is written to. So we chose Kinesis for that particular option, and then we wrote some bash scripts because the data were both streaming data and data at rest. So data in motion or data at rest. What we did was to ensure that the data being transmitted is actually moved in a form that we can use Kinesis to move that data from one location to the other. And then for the bash scripts, there were cron jobs, background processes that were daily pulling data from those locations and dumping them in the data swamp, which is the next step, which is storing this data in a temporary location, which is the data swamp. So after extracting the data, the data becomes in a form that you need to dump in a particular location. And then we use S3 as our data swamp, which was the first stage of dumping the data. Before we can actually get business value out of the data, we need to even look at and understand what even exists in this data. What are we trying to extract? What are we trying to do? What problem are we trying to solve? We know the problem we're trying to solve, quite all right, but we need to understand what we have, if it can solve the problem, how we can engineer the data that exists to solve this particular problem. So the third step was to scan through the data in the data form to have a bird's eye view of the data. So there were different data that existed. We have data from the campaigns. When a campaign is done, the user has a journey. The user goes from websites A to B to C to D. The user exits the browser. We need to understand what actually exists in terms of the raw data that we have existing. Based on what we understand and based on what the business needs to get done and what the business needs to get delivered, the next thing we did was to actually look at how we could build a transformation layer that helps to compress, merge, and flatten the data, removing noise or unnecessary parts of the data. So that was what we could do, because we now understand what the data has. We now understand what is in our data swamp. We now understand what exists there. So when we did that, we were able to build that clear transformation layer using tools like Amazon Glue to clean up the data and put it in a form that is going to be more valuable to us. The next stage was to build what we call a data lake. Now, the data lake is where the data we have transformed, the data we have cleaned up that now looks much better, this is where we eventually write that data into. So at this point in time, the data starts making sense because we have removed the noise, we have removed what we don't necessarily need anymore, we have removed the data that is not so relevant for improving the performance of the campaigns. And then the next stage was to use an analytics tool to scan through transformed data that needs to meet the needs of to see if it meets the requirements. So there are certain requirements we have. We're trying to improve campaign performance based on the data that we have. So in doing that, we had to look at what has been transformed. Does it conform to what we want? Does it meet what we want? There are some cases that we actually did not perform transformation well. We will have to go back to the transformation process, retransform the data, and bring it back to the lake and then reanalyze. So it's more of a continuous process. I call it continuous ETL, okay? Just like DevOps, where you have continuous integration and continuous delivery. So ETL is a continuous process of continually fine-tuning that data until you get the best kind of data and solve the business problem you're trying to resolve. When that is done and we are sure that the data is clear enough, then you have what you call pushing data over for analytics and for ML and model training. So this is where SageMaker comes in. So from this point in time, we'll plug our data into SageMaker using the SageMaker connector, connects to S3 directly, and you can build a model around that you can train, because you now have data that you trust, data that has been cleaned up, data that is ready to go into the training of the model so that model can be very efficient and meet with the business goals that you need to achieve. So this all came down to an architecture that looks exactly like this. So the architecture is first of all, we have data in our EC2 instance, or this could be an RDS instance, or any other kind of storage where we have the logs, database information and everything. So the first thing is to extract this data and take it through Kinesis Firehose. But what we have that we use for this extraction is what we call the KCL, which is the Kinesis Client Library. Now, Kinesis Client Library can sit as a daemon process in your server. What it does is that it pulls data from a particular location and pushes it through Kinesis. Okay, it's more of an API call. It takes the data in batches and pushes it through Kinesis and calls the Kinesis API to push the data over to the data lake. But before the data gets to the data lake, we need to perform transformation and we need to check what if we have 6 columns in this data, how many columns do we need? 5 or 4 or 3? Okay. At this point in time, we get rid of noise in the data. Any column or any data point we know is going to cause is going to give us wrong results. Okay, we get rid of it at this point in time, and that's where the Lambda function comes in. So the Lambda function is a serverless service that can help you deploy applications for various purposes and reasons. I won't go too much into Lambda functions today, but there's a lot you can do with Lambda function. But at this point in time, we use Lambda function to clean up the data, perform the first layer of transformation on the data. So as the data moves through the Kinesis Firehose, we are transforming the data and writing it eventually into S3. As it moves through Kinesis Firehose, a Lambda function is triggered. It looks through the data, checks if there's any noise in that data, remove the noise, and then writes out the output into S3, while the raw data still exists in the data swamp. So as our data swamp is growing, our data lake is growing, because we are continually dumping the raw data in the swamp and then also writing it through Kinesis Firehose via the Lambda function that cleans it up, and then eventually to the data lake storage. And then when it gets to data lake storage, the next thing that happens is that Glue crawls through the data. So apart from Glue being an ETL service, Glue can also crawl through data in S3. And what that does for you is that it helps you to standardize your data for Athena querying. So with Glue crawling through the data, it's able to actually classify that data for you. If it is a Parquet data, if it is JSON data, if it is CSV data, and that classification can be very helpful in understanding the schemas and a lot of other information about your data that you just performed your transformation on. And something that's very interesting about this is that when you are able to cross that data with Glue, it makes Athena, it makes it very easy for Athena to work with that data and query that data and gives you proper visualization of what exists in that data. Now, part of the things we also did for the Lambda transformation was also data compression. So I talked about data compression before, I'm talking about it again. So in data engineering, compression of data is quite critical because when you're moving terabytes of data, you don't want to move that all the time because it can be very time consuming, it can be very cost consuming because you spend a lot of money transferring data, whether you're transferring cross region or within your AWS account. And it's also very difficult for analytics services, okay? Even when you're training your models, if your data is not properly compressed and easy to work with, it becomes difficult for those models to get properly trained. So compression of the data is quite important and very good. So what we use for this compression is actually Parquet, okay? P-A-R-Q-E-E-T, Parquet. It's a very good format for compressing JSON or CSV data into, and it's quite readable by a lot of libraries, a lot of plugins. Even within your SageMaker notebook, you can actually query and read and Parquet data. So though it's compressed, you can't view it with a text file, but it's actually viewable by a lot of other services. So that was what the Lambda transformation also did. Apart from just cleaning up the data, it was able to compress the data. And then eventually when it gets to Athena, Athena beautifully can read Parquet data. So you can actually query your compressed data, which saves a lot of data transfer from S3 into the Athena service. And then your queries become almost 5 times faster than the original JSON or CSV format that you had that data in. So basically, the machine learning services or frameworks in AWS, I already talked about Amazon SageMaker, how we use Amazon SageMaker to train the data. So to train the model. So after data is available and ready, the last stage is actually either analytics or machine learning using Amazon SageMaker. And we also use scikit-learn too as the algorithm to particularly train the model and deploy the model when we are done. And whenever we need to train the model, we go through the ETL process. The serverless ETL pipeline cleans up the data, makes it available. SageMaker reads from the S3 bucket, that's how the data lake, and we are able to deliver more value at the end of the day. Thank you very much.
Thank you so much, Mr. Awere. That was very comprehensive, very deep, and very enlightening. Thank you for sharing with us on data engineering on AWS. Thank you so much. I want to welcome Griffin to take us through a short Q&A session. Then we can continue from there. Thank you so much.
Hello everyone, we have shared a Slido link with you to be posting your questions and respond to one poll over there. And so far, 75% of you in the poll say they are new to AWS and want to understand the basics, while the other 25% agree that they are somewhat proficient and want to get insights and opportunities about AWS. We don't have, we only have one question so far. And still want to encourage everyone to keep pushing your questions for the speakers over there so that we are able to get them at the tail end of their presentation. So keep pushing your questions on to the link that is shared with you on the screen. Thank you, Lydia.
Thank you so